Okay. So last time we talked about the, let me start here from the class reps. Did you manage to elect your class reps?
Yeah, it's me, sir.
Okay. You are two, the class rep and his assistant. Yes, Manyama?
Yeah, I'm the class rep, yes, sir.
You are
Manyam,
the only
the
one.
mail.
You are the only one. I'm asking whether you are the only one who is a class rep. Is it Manyama? Taviso? Eh?
So we didn't pick any class rep. I guess
You
we
didn't have
should
time
pick.
to. Okay.
Yeah,
So please,
we
can
can.
you please do that and send me the names as soon as possible?
Okay, sir. We'll do that.
Yeah, okay, thank you very much. Okay. Let me just do something before we proceed here. While we are still waiting for others to join. Okay. Just upload my files while we're still waiting. Okay, while I'm still waiting for the file to be uploaded here, let me just say this. Today I'm thinking of using another window here. It's called Window Journal. So in that window, the disadvantage of that is that I can't be able to see you when you raise your hand or comment, but rather I can just allow you to use the mic, to unmute your mic and then raise a question if you have a question. So that is the only disadvantage. I won't be able to see you raising the hand or commenting. So, but rather you can just use your mic to raise your question. So I think it's going to be a wonderful window, because for the previous ones, it was very small in such a way that when I write things, I have to erase quickly, and maybe it was a disadvantage to others. But this one, I can write it, and then if the page is full, I can just proceed to the next one. If you didn't understand the previous one, I can go back and then try to explain. I think it's clear to everyone, isn't it?
Yes, sir. It's clear.
Okay. Okay. But I'm still waiting for the file to be uploaded here, and it's taking time. And I should have done this before you just log in, but rather because of the challenges that I was explaining, I couldn't. Okay. Let me see what I can do. In the meantime, let's go there. Okay. Can you be able to see my page? Can you see the page?
Yes,
Yeah, we
sir.
can see
Yes,
that.
Okay, thank you very much. So let's start now. If you recall, last time we talked, but please unmute your mic so that we can understand each other. If you recall, last time we spoke about the method of isolating a trend, and I introduced two methods. The first one, can you please mute your mic so that you can understand each other, please? Okay, thank you. So the first method was moving average, and the second one was a regression line, or sometimes they call it least square regression line. So we try to calculate the 3-year moving average, 4-year moving average, and 5-year moving average. We've done that. I think everybody now is clear on how to calculate the 3-year, 4-year, and 5-year moving averages. So now, today, we are going to proceed with the regression line, where we have to fit a straight line. So if you recall, remember, this is the revision of what you know. If you recall, the regression line is defined by this equation, y, which is equal to beta 0 plus beta 1 x. So in other books, they just use beta 0, they use as a, and beta 1, they use as their b. So the question is, what does this variable y represent? Y represent the dependent variable, okay? And variable x represent the independent variable, okay? So what about beta 0? Beta 0 represent y-intercept, okay? And then beta 1, it's a what? It's a slope or gradient. You see? So if you want to fit a regression line or straight line, you use this equation, y equal to beta 0 plus beta 1 x. So where y represent dependent variable, x variable represent independent variable. Beta 0 is a y-intercept, and then beta 1 is a gradient or a slope. Where beta 0 is equal to y bar minus beta 1 x bar. I think you are familiar with this. And then y bar is the sum of x divided by n. It's sum of y, sorry. Sum of y divided by n, and x bar, the sum of x divided by n. So what about the beta 1, which is our slope? It's equal to n times xy minus summation of x times summation of y, all divided by n times summation of x squared minus summation of x all squared. I think it's clear. So this is how we define those parameters, beta 0 and beta 1. Okay. So now, if you recall last time, I gave you the time series data, small time series data with the actual values. I think it's 2, 6, 1, 5, 3, 7, and 2. Those are the actual values that I gave you last time. Now, if you just want to fit a straight line or a regression line, when you have been given this type of a time series data, it will be impossible. Why? Because you do have only having one variable, which is y, and we don't have x variable. So you can't fit the regression line if you don't have the x variable. So what do? We just code the variable x. In order to have all those actual values for variable x, you have to code it. So how do we do that? So there are two methods that you can use for coding the variable x. So coding method for coding variable x. Number one, you have to use what we call the sequential numbering method. That is the first one. First method that you can use to code the variable x is called sequential numbering method. This is the first method that you can use to code the variable x. Another method is called zero sum method. It's called zero sum. Zero sum method. So those are the two methods that you can use to code the variable x altogether. Now let's start with the first one, sequential numbering method. How do you code the variable x using sequential numbering method? In this case, you just list them in ascending order, starting from 0. The first one is going to be 0, 1, 2, 3, 4, 5, and 6. So this is how you code the variable x using sequential numbering method. If you have any question, please unmute your mic and then you ask the question. I will answer you.
Sir,
Okay.
I wanted to know that which numbers are we listing? Are we listing the y variables or the x?
The x variable, isn't that the y variables are the data that you came with? We used
So
it
when
last
we
time.
list the x, we don't take them from the y.
You don't take them from the y. You just come up with all those numbers starting from 0,
Okay.
depending to how many actual values on the y variables.
Okay, sir.
Just
Thank you.
list them starting, but start from 0 until to the last part. Okay. Now, this is how you do it when you are coding the variable x using sequential numbering method. Start from 0, 1, 2, 3, 4, 5, 6, and then you stop. I think it's simple and straightforward. After getting this one, this is how you can code it. And then when you want to fit the regression line, so it's possible now because you have got the x variable. You know how to proceed from this one. Okay, I hope so. But anyway, you will do the exercise later. So let's allow me to just give you the theory on how to do it. Then later we are going to do the example related to that. So now let's go to method number 2, which is a zero-sum method. So for the zero-sum method, you are still going to use the same example there. So for zero-sum method, what you have to do, you must find n. You have to find your n there, small n. You have to find small n. What is the meaning of small n? Small n represents the sample size, isn't it? So you have to find the sample size if you want to code the variable x using zero-sum methods. Start by finding the sample size n. So how do you find the sample size n from the data? It's simple. You just count the number of actual values there. How many are they? Starting from here, 2, 6. So it's 1, 2, 3, 4, 5, 6, 7. Okay. There are 7. Are we together? N equal to 7. N stands for the sample size. And our sample size is 7. After getting that sample size 7, remember, we just want to code the variable x. Let me just draw a line again here. Okay. So we just want to find the variable x. This time is for zero sum. The second column was for sequential numbering method. So for the third column is going to represent the what? The codings of variable x using zero sum method. So now how do we do it? So let me say to find this value here, a, the first value for the variable x, a, you use this formula. A equal to minus open brackets n minus 1 close brackets divided by 2. Okay. To find the first value here, you use this formula, a equal to minus open brackets n minus 1 close brackets divided by 2. But remember, we have already find our sample size n, which is 7. So it's simple. You just have to do n there by 7. 7 minus 1 is 6. 6 times minus is minus 6. Minus 6 divided by 2. So the answer is what? Minus 3. The answer is minus 3. Let me write it nicely. Okay, the answer is minus 3. So therefore, here, the first value is, the first value here is minus 3. That's our first value. Start by finding the sample size. Then you have a formula, you substitute your sample size by the value that you got there. Then you divide it by 2, you find the value now is minus 3. Now, the question is, how do you find the next one? To find the next value, you add 1 from the previous value. In other words, you have to add 1 from -3. So in other words, -3 plus 1. So the answer is what? -2. To get the next value, you add 1 from the previous one. In other words, you add 1 from -2. And the answer is what? -1. Okay, any question? None. Okay. -1. Then you add 1 again to get the previous one. 0. You add 1, 1. You add 1, 2. You add 1, 3. Okay. Is there any question? So mute your mic. So now, the first value is -3. To get the next one, you add 1, -2, add 1, -1, add 1, 0, add 1, 1, and so on. Then immediately when you reach the last one, when you sum them up, your answer must be 0. So that is why we call it a zero-sum method. Any question before I proceed? None. Okay, I think it's clear. Now let's suppose your sample size is even. Huh? Do you have any question?
Methods of
Yes, ask. I didn't get your question.
how
Please repeat it. And you're
methods are used
breaking.
to code for X.
Come again.
How
I didn't get your
methods are
question
used
yet.
to code for X.
I'm struggling to get you. You're breaking. I can just hear.
How many
Oh,
methods are
how many methods?
to code for X?
Is there anyone who can explain what is she's
She's
talking
saying
about?
how
Because I
many
can't
are there for coding for X?
even you're breaking. I can't get the last part.
How many
methods?
methods are there for coding X?
Oh, how many methods are there for coding X? For now, we know there are 2. The first one is sequential numbering method and zero-sum method. And then it won't be difficult for you to select which one do you supposed to use, because I will ask you, use zero-sum method, maybe to fit a regression line given the what?
Say, there's
The time.
I'm asking a question.
Sir,
Yeah.
sir. So when our n is even, what do we do? What do we do when we
Yes,
are
it's what
using
I
the
wanted
zero
to
sum
explain
method?
it now.
What's the formula?
Yes. Okay.
Okay.
Okay. So now I can proceed to
Sir,
explain
sir,
when n is odd.
sir.
Yes.
Before you proceed, someone was asking you to please repeat the sequential because the person doesn't understand.
Oh, okay. Okay, let me just repeat again. From the beginning, I said there are 2 methods that you can use to code the variable x. I said the first one is sequential numbering method and the second one is a zero-sum method. So in case of sequential numbering method, if you have been given the time series data and you want to code the variable x, you just list them starting from 0, ascending, starting from 0, 1, 2, 3, depending to the number of a sample size. How many are they? Then you stop. Just list them from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, depending to the sample size. Then you stop there on the last one. Simple. Just list them. I don't know whether you understood me.
Yeah, I did. Thank you.
Eh?
Thank you.
Okay,
I
thanks.
did.
Okay. So now let's go to when the sample size is even. For argument's sake, let's say you have got a time series data like this one, which is represented by, I don't know whether I can just draw another one somewhere. Okay, let me just go to the next page. Let me just go to the next page so that it can be simple. Okay, let's say you are having the time series data again. You're having 2, let's say 6, 1, 3, let's say 5, 2, 4, 5, and then let's say 7. Okay, so you see now your n here, if you check, n equal to 6. Okay, because it's 1, 2, 3, 4, 5, 6. N equal to 6. So your n now, this n is odd. It's even, sorry. This n is even, sorry for that. It's even. Okay. So in this case, if n is even, to get variable x there, to get the first value, let's say a, you use this formula. A equal to minus open brackets and minus 1 close brackets. If n is even, to get the first value, which is a, use the formula a equal to minus open brackets and minus 1 close brackets. So now, because our n now is 6 there, so you can substitute there and get 6 minus 1 is 5. So the answer is 5. So therefore, our first value here is what? It's minus 5. Are we together? So in this case, to get the second value on that variable x, you have to add 2 from the previous value, which is minus 5. In other words, it's minus 5 plus 2. And the answer is minus 3. Add 2 again, minus 1.
Why do you
Okay.
add 2?
Oh, this is the procedure. Why do we add 2? That is a procedure. Remember, when n is odd, we add 1. And then here, when n is even, to get the second value, you add 2. That is the procedure, and 2 is an even. That is why we are adding 2 there. And there, that is why we add 1, maybe because 1 is an odd. But that is a procedure. You don't have to analyze it. I think it's clear. Okay, then the next one, you add 2, you get 1. You add 2, you get 3. You add 2, you get 5. The interesting part is that when you sum them up, they must give you 0 because it's a zero-sum method. Okay, I think it's clear, unless you have any question. So these methods, you can find them on the lecture notes from page 15 or page 14. 14 and 15, they are there. Any question? None. Okay. So let me proceed. Let's go to the next page again. And then now we just want to calculate the seasonal index. calculating seasonal index. Seasonal index. So the main idea here of calculating the seasonal index, we just want to measure the seasonal variance. That's the main idea. Just want to measure the seasonal variance. Or seasonal variation, whatever you can call it. In other words, we are measuring the change in the demand. So what are the steps that you can follow in order to calculate the seasonal index? Or indices if there are many, or index if it's one. Steps for calculating seasonal index. So we have got 4 steps for calculating seasonal index. First one, step number 1, you calculate what we call seasonal ratios. Calculate seasonal ratios. Okay, and it is defined by this equation. SR stands for seasonal ratio. It's equal to YT over MA multiplied by 100%. Okay, that's step number 1. That leads us to seasonal index. You calculate the seasonal ratio. Seasonal ratio is defined by this equation or formula. Let me call it a formula. YT divided by MA multiplied by 100%. So what is the meaning of YT? YT stands for the actual values. Actual values. It's the actual values on the data sets. So what about the MA? It's a moving average. Here normally we use 4-year moving average. And remember, 4-year moving average, there is centered one and uncentered one. But here we are going to use the centered one. Centered 4-year moving average, centered. Then you multiply it by 100%. That's step number 1. Step number 2, you calculate what we call unadjusted seasonal index. Unadjusted seasonal index. That's step number 2. You calculate what we call unadjusted. Sometimes we call them median seasonal index. Okay. Step number 2, you calculate unadjusted seasonal index or median seasonal index. Step number 3, you calculate what we call adjusted factor. Adjusted factor. And it's defined by using this formula. K multiplied by 100 divided by the sum. The sum of...
Sir,
Yes, yes.
what is that word after adjusted?
Oh, it's a factor.
Oh,
F-A-C-T-O-R.
okay.
Adjusted factor, which is equal to K multiplied by 100 divided by the sum of what? Step number 2. Unadjusted seasonal. Index. Yeah, then you close the bracket here. Step number 3, you calculate an adjusted factor, which is equal to K multiplied by 100 divided by the sum of unadjusted seasonal index, or the sum of median seasonal index. So, where K equal to 4, if the data is quarter. If you have a quarterly data, you substitute your K by 4. Say if let me just say if for quarterly data, K equal to 4 for quarterly data. For quarterly data. Okay? If your data is quarterly, you substitute K by 4. But if your data is monthly, your K is equal to 12. So if you are dealing with the monthly data, your K will be 12. If you are dealing with the weekly data, your K is 52 and so on. But in this module, we are going to consider only K equal to 4 and K equal to 12. If K is 52, that's going to be a big data. So we can't deal with the big data there. So we're going to deal with only 2 data sets, K equal to 4 and K equal to 12. I think it's clear for step number 3. Okay, let me just go to step number 4. Step number 4.
So, sir, how
Oh,
do
you're
we
still writing?
calculate the unadjusted seasonal index?
Yes, I'll show you how to do that. Don't worry. I will show you. We are going to take an example, then we try to follow all those steps. So can I go to the next page? Okay.
Yes, sir. We can go.
Okay, thanks. Okay, step number 4, which is the last one. You calculate your what? Your seasonal index now. So how do you calculate the seasonal index in step number 4? Seasonal index here. It's equal to adjusted factor, okay, multiply by the unadjusted seasonal index. So I'll show you how to do this one because you'll be asking how to do this. So step number 1, you have to calculate the seasonal ratios. Step number 2, seasonal ratios. Step number 2, you calculate the unadjusted seasonal index or median seasonal index. Step number 3, you calculate the adjusted factor. Step number 4, then you calculate the seasonal index. Think it's clear? So now let's find the example on how to do this. You still recall that on Monday, if it's not Monday, it's Tuesday, I sent you
Someone
an
is asking if we
exercise.
divide or multiply.
We multiply. Seasonal index equal to adjusted factor multiply by unadjusted seasonal index. So I sent the exercise number 1. I said you must go and calculate the 4-year moving averages. Have you done that? And I said we are going to apply those solutions in the next lecture. Have you managed to do that? You did?
Yes.
Okay. So now let's try to use that exercise to calculate the seasonal indices. Okay. Don't know what. Or maybe you are going to use that one to calculate your own seasonal indices. Because that one it was long, let me just consider this small data set. I think it will be easy for us to calculate. Let me just try to check. Let me try to check the data. The simplest one so that we can be simple for us to calculate. Can see it now. I'm trying to find out what we've done last time. Okay, let's consider this. Let's consider this data. Two, 6, 1, 5, 3, 7, 2. I think it's the same data that we've been using all along. Okay. But remember, in this case, we've got the 4-year moving average. We've already calculated the 4-year moving average centered. Remember, if they just gave you the data like this one, and they say calculate the seasonal ratios, you must first calculate the 4-year moving average uncentered and 4-year moving average centered, so that you can use those 4-year moving average centered when you calculate the seasonal ratios altogether. So, but however, in this case, we've already calculated the 4-year moving average, if you still recall. We've already calculated this. We've already calculated this 4-year moving average. Isn't it? So let's just put, we're not going to
Yes.
recalculate it. Put the values. If I'm making mistake, you call me, you tell me 2, 7, 5, 8, 6, 129, I don't know. No, it's not this one. I think I'm making a mistake, ne? These are not the values.
Yes, those are not the values.
You're making a mistake.
3,
3.5.
yes,
3.625.
and 3 point.
It's 7.
Oh, 3.625.
3.625.
Okay, yeah. Yeah, 625. Yes, you're right.
Yes.
Then the next one, 3.875.
Yes.
Okay. Then the last one is
125.
4.125.
Yes.
Then the last two, they are dashes, isn't it? Yeah.
Yes.
So remember, we want to calculate the seasonal index here. We want to calculate the seasonal index. So the next step is to calculate the seasonal ratios, SR, for the next column. Then after calculating SR, you calculate the seasonal index, I think so. Yeah, then seasonal index, SI, is the seasonal index. This column, the third column is SR, which is a seasonal ratio, and the last column is a seasonal index. So let me show you how to calculate those things now. Remember, to calculate the seasonal ratio, SR, it's equal to YT over MA multiplied by 100%. So we just want to find the first value here. You are supposed to have what? The YT. YT is this one. The first column is this one. It's the actual. The actual values. Those are the YTs. This one going down. Okay. So that means we have got what? 2 as a numerator. Then divided by a moving average. A moving average is what? 4-year moving average. It's a dash, isn't it? Then multiply by 100. Obviously, you're going to get a what? A dash. The first one is going to be a dash. Okay. The second one, again, is going to be a dash. Are we together? Now, the third one. Now, let's calculate the third one. The actual value is 1. You see that one? Okay. Then you divide it by 3,625. Then you multiply it by 100. Then you tell me the answer. Okay. Let me just calculate it for you and see. 1 divided by 3,625 multiplied by 100. It's 27,586. Are we getting the same answer with it?
Yes.
27,586. 6. So this value, you put it here. 27586. Okay. So you do the same for the next one. You take 5, then you divide by 3,875. Tell me the answer.
Sir,
Yeah? Yes, talk.
It's
when we are calculating
129.032.
that percent,
129,32032.
For which one?
Next
Come
one.
again. Is it the next value?
Yes.
Okay, it's what? Come again.
129.032.
129.032.
Yes.
Okay. Is everyone getting the same answer? If you are getting the different one, please let me know. The next one is 3 divided by 4, 125.
72.73.
72.727.
Huh?
We're saying 3
Yes,
divided
it's
by
72.77.
okay.
Also
72.727.
2.727. Yeah.
You're getting the same answer. So this
Yeah.
one obvious is dash dash. Okay. So here in column number 3, we're doing what? Step number 1. Are we together? That's step number 1. Okay. So now let's go to step number 2. Okay.
Sir, can I ask?
Any question? Yes. Yes.
I have a problem. Since those these dashes, they were
Dashes.
supposed to be in between those numbers. So do we on the what the SR also put them in between?
It's not in between this one. You see, it has to correspond with the actual values.
All right, sir.
Yeah. Okay. Any question? Okay. Now let's go to step number 2. Step number 2 is to calculate what? If you still recall. I can erase this. Is to calculate unadjusted seasonal index or median seasonal index. So this one, let me just open the next page. We'll come back to this one. For this one, we are going to have a table here. Let me start with quarter 1, quarter 2, quarter 3, then quarter 4. Okay. And then normally, if you check, let me go back. If you check the actual data, column number 1, you can divide your values into 4. Okay. You can just say like this one, just because this is the small data, so it won't give what we want. 1, 2, 3, 4. You can take it as year 1. In other words, it's This value is for quarter 1, quarter 2, quarter 3, and quarter 4 altogether. And the whole of this is year 1. Year 1, you can just, it's year 1. Okay. And again here, you have to have quarter 1, quarter 2, quarter 3. We were supposed to have another value here for quarter what? 4, but we don't. Just because we took the small data set. And this one is year 2. You can just name it if you want. You can just say this one is 2000 and let's say 2020. You can say 2020 here. And this one you can say 2021. I'm just giving you the scenario. 2021. So this is how you have to split your data. Split the data into quarters. Quarter 1, 2, 3, 4 for year number 1, 2020, and quarter 1, 2, 3, 4 for year number 2, which is 2021. So now, so that means this line can continue like this, and this one continue like this. Okay. So now we just want to calculate what? The median seasonal index or the unadjusted seasonal index. That is why I ended up having these quarters. Quarter 1, 2, 3, 4. So we've got 2 years here, year 1 and year 2. So, okay, let me just use this one. In this case, we've got year 1, this thing. Year 1, which I called it 2020. So it's going like this. And year 2, which I can call it 2021. I just choose the year randomly. You can use 1991, 1992, 1999, 1910, like that. Just choose them randomly like that. Then, so even here, this is what we are going to have. Okay. So now, if you can check here, in the previous page, if you check here, quarter 1, the seasonal ratio is a dash, isn't it? For quarter 1, seasonal ratio is a dash. So we are trying to put the values of seasonal ratio. For quarter 1, it's a dash. Okay. Okay, for quarter 1, it's a dash. Quarter 2, again, it's a dash under seasonal ratios there. Okay, then we have to put a dash again. Then for quarter 3, the value is what? 27.586. And quarter 4, the value is 129.032. So we have 27586. $27586. Then the next one, quarter 4, 129. 129 point what? 0.032. Are we together? We are just listing the seasonal ratios. For quarter 1, it's a dash. Quarter 2, a dash. Quarter 3, a number. quarter 4, that number. Then 2021, so 2021 for quarter 1 is 72 point something. 72 point what? 727. Okay. So for quarter 2, I think it's a dash. Those other ones are dashes. They are dashes in the sense that you see that quarter 2 is a dash, this one is a dash. And the rest is a dash. So remember, we just want to calculate the median seasonal index or unadjusted. Yeah, so because our data is so small, you won't understand it when I explain. But anyway, just listen. Here now you have to check quarter 1. Quarter 1 column, can I call column number 2 with a dash and a value. Let me show you what I'm talking about so that you can understand. You have got a dash, okay, and this value. Because here we've got a value and a dash. Actually, we were supposed to get the median of the two. Do you still remember what a median is? If you have got the values, you arrange them in ascending or descending order. After doing that, you take the middle one, and that middle one, we call it the median. So we are going to do the same here. However, here we've got only two values. Let's say it's 1 or 2 because there is a dash there. If there are two values, you know that to find the median, you just get the average, isn't it? But because here we've got a value and a dash, there's no need to get an average because it's a dash and a value. You just take one value and put it there as your answer. So therefore, here the value here is in the second column is 72.727. And this last row here, yes, we are calculating the median seasonal index. We are calculating the unadjusted seasonal index or median seasonal index. That is the last column. And the value of the median seasonal index of quarter 1 is what? 72,727. Okay. For quarter 2, obviously, we're going to get a dash. We're getting a dash just because we have used the smallest data set. We were supposed to use the bigger one. So this is the disadvantage of using the small data sets. So it's like a missing value. You get that? So for quarter 3, you're going to get 27.586. Okay. So here, I think because it's a missing value quarter 2, I think we're supposed to have a, okay, just put a 0. Because it's a missing value, we don't have a value there. So quarter 4, it's 129,032. Therefore, the last column here, you have to find the total in the last column. So to find the total, you add everything, all the median seasonal indices for each quarter. So in other words, you're going to add 72.727 plus 0 plus 27.586 plus 129.032. What is the answer? What is the answer?
Sir, you said we ate what?
The last column. So those numbers on the last column.
The median
72,
seasonal index, sir.
yes, you add all of them and give me the total.
Okay.
229.345.
229.345.
229.345.
Is this one?
Yes.
Okay, this is the sum of median seasonal index. Okay, that's step number what? Number 2, isn't it? Okay, step number 2. Now let's go to step number 3. Let me just continue to the next page. Here step number 3. In other words, here we calculate what? Adjusted factor, remember? Which is equal to K times 100 times sum of seasonal median seasonal index. Let me just call it prime. Because it's going to confuse you. It's going to confuse you. Let me just write it as it is. Unadjusted seasonal index. This is the formula. So in this case, because we are dealing with the quarterly data, if you check, this is a quarterly data. It's divided into quarters, quarterly data. So therefore, your K is 4. Because we are dealing with the quarterly data there. Then divided by the sum of unadjusted. The sum is 2229. 229.345. 325.
Yes. Yes.
Then give me the answer, please.
345.
345.
Yes.
Okay. Give me the answer. Final answer. 400 divided by
1.744.
1.744.
744.
So this is an adjusted factor. Then step number 4 is the last one. Okay, what do you do? Step number 4. Remember, it's seasonal index, which is equal to unadjusted seasonal index times adjusted factor. Unadjusted factor for, in this case, you take this one. You take the first unadjusted factor here, unadjusted seasonal index for column 2. In other words, the first value is 72727. 72727. Then you multiply by what? By that factor. 1744. 1744. Then you tell me the answer. Remember, it's for quarter one. Seasonal index for quarter one. Okay. You do the same for
126.
Come again. Come again.
126.83.
0.83. So we
36.
found the seasonal index. Eh? Is it the correct answer? The 126.83.
83.
I don't get the last part. Eh?
It's 126.836.
836.
Yes, sir.
0.386.
This is what I wrote here. 126.836.
Yes, yes, sir.
Okay. So seasonal index for quarter two, you go back there, you take the unadjusted seasonal index for quarter one,
Dash.
which is 0. So obvious this one is going to be 0. 0. Then seasonal index for quarter three, it's 27,586. 27, is it 586?
48.1011. 48.11.
48.11. Okay.
8.110.
48.10. I suppose. Come again.
48.110.
Oh, okay. Yes, to 3 decimal places, please. Very important.
Sir,
Eh?
on adjusted factor, the answer is not 1.336.
For which quarter? Adjusted factor.
Yes,
It's not 1.744.
I got 1.336.
What? It took 400 divided by 229,345 and got
Yes.
1.336.
336.
Let me just verify, because there are those who are just copy. 229.345. What is the
It's
answer?
1.744. No, the answer is 1.744.
744.
Yes.
It's still
How
right.
did you get 1.3 something? This is the correct answer. Be careful. For quarter one, seasonal index for quarter one. Quarter one. For quarter four, man. Is it
Quarter
quarter four?
Yes.
It's quarter four, ne? 127.
Yep. 129. 129.
Okay, let me just write the answer anyway.
It's not
129.
the answer.
I need the answer. I know how to calculate it.
225.03.
The answer is 225.
Point
032.
225.032.
Yebo.
away.
Is that the correct answer for everyone?
Yes.
Okay.
Yeah.
Now you have quarter one, quarter two, quarter three. Then you substitute them in the where is it? the table here. Yeah, you have to read it here. Can you read them for me, please, again? For quarter one?
126.
1.836.
126?
0.836.
Can you hear me?
836.
836. The
0.
next one? Yeah. The next one?
48.1.
Oh yeah.
48 point.
110.
The next one?
225.032.
Now, then you repeat the same thing here on year number 2, which is 2021. Just repeat them as they are. 126 for quarter 1, 836, then 0, then 48.110, then the last one is 25.032. So this is how you find the seasonal index or seasonal index. So what time is it now? 36. Okay. Let's go back to our exercise. The exercise that I gave you on Monday or Tuesday. If you haven't calculated the 4-year moving average center, just go and calculate them. And then you calculate the seasonal ratios. After calculating the seasonal ratios, then you calculate the median seasonal indices. Then you calculate the adjusted factor. Then later you calculate the seasonal index. After doing that, the next part is I want you to go and fit, using the same exercise, fit a straight line or fit a regression line using sequential numbering method. That's number 1. Number 2, using zero sum method. Because we still have time here, calculating the, where can we start? Let's fit the regression line using the same exercise. Let me see whether I can be able to. Did you get it? The exercise that I gave you on Monday or Tuesday. Just fit a regression line using use zero sum. Then from there you find the seasonal indices. But now, because we still have time, let's feed the regression line using sequential numbering method. That's number 1. Okay, let me just write down so that you can recall. So that you can recall them. Okay. You just call it exercise number 2. From exercise 1, calculate OA, fit a regression line using sequential numbering method. Number B, fit a regression line using zero sum method. Number C, calculate the seasonal index. I think it's clear. Number one, you fit a regression line using spatial numbering method. Number two, fit a regression line using zero sum. Number C, calculate the seasonal index. So for now, you are starting with number A. Now, let me just try to upload that thing, that question. Exercise.
Sir,
Yes,
sir,
come, ask your question. I'm waiting.
Are we going to have tutorials today?
No, we're going to start with our tutorials next week. But however, if you have maybe some challenges, you can drop an email.
sir, can
Okay.
sir go to start
Yeah, I can't get your question.
N4 on the previous exam?
You're cutting. I can't get the question. Just ask it again. I can't hear you. Please ask. I didn't get your question.
Network, sir.
Oh, network.
Mm.
Okay, can I go back to? Can I stop sharing here?
Yes,
Yes.
sir.
Oh, okay. Mm. Okay, let me. So you can write your message here if you. Say on the sequential method, what if I assign my first value of 1, not 0? Will I be wrong? No, on the sequential numbering method, to be on the same page, I think it's better to just start by 0 rather than starting by 1. However, even though you start by 1, I think there is no harm on that. But to be uniform, let's start from 0. Okay, any question? Do we have a class today? No, today, on Tuesday, we won't have a class because the laptop that I'm using, I'm sharing with my colleague. And at that time, we'll be busy having a class. So the tutorial for Tuesday, let's take it out. Then we're going to have tutorial sometimes on Wednesday. In other words, we're going to have classes on Wednesday and Friday. Remember, on Friday, they are double, starting from 7 until, is it 10 past 9 or something like that? And then Wednesday, starting from 10 past 11 until 10 to 1. And then again, I think on Wednesday, we are going to have tutorials. But anyway, we're going to start with those tutorials next week. On that activity, whether you are going to use monthly data or quarterly data, yeah, I think it's quarterly data. Use quarterly data, that one. You're going to use quarterly data on that exercise. Another question? There's no other questions. If we have two values on calculating the median as well, do we add the two values and divide by 2? Yes. If you don't know the procedure of finding the median. To find the median, if you have got two values, you find the average. That's it. If you're having three values, you arrange them in ascending or descending order, then you take the middle one. I hope you know the procedure on how to find the median. So we are finding the median there. We are not finding the mean. Be careful on that, because others, they will end up finding the mean. We're finding the median. However, when you find the median, sometimes there is a procedure that is the same as the one that we are using to find the mean. Any question? Again, when you feed the regression line, if the question says feed a trend line, it's the same formula. You're going to use the same formula. Isn't that for the regression line, you use y equal to beta 0 plus beta 1 x. So for finding the trend line, you use t equal to beta 0 plus beta 1 times x. The only difference is that we remove y by t in order to fit the trend line, but it's the same formula. And another thing that I've missed, I'm recalling now. Let me just try to show you something. Show you something. Show you something. Show you something. Can you be able to see my notes there?
Yeah, we're seeing something.
Okay, let me just explain something so that you can be clear on zero sum. Okay, let me just go back so that it could be simple for you. You still remember these formulas, okay? Now, I said if you want to find beta 0, you use this formula for beta 0. Now, in this case, because let's say you want to fit the regression line using the zero sum method. So in this case, to calculate beta 0, now you're going to have beta 0 equal to y bar minus beta 1 summation of x of
Sir, I can't see where you're writing.
You can't see.
Yeah.
So there are those Eh?
Even
too.
sir, my question was for you to go to the previous example which we did, step 3 and 4. I just want to confirm the numbers. I was out because of network. There is load
Okay, okay.
shedding.
Okay, I'll go there. But for now, can you be able to see what I was writing? Because there is
No.
some.
No,
No.
what you really?
No.
Oh.
Anything.
Eh? Can you be able to see the page?
No.
No.
Oh,
No.
okay. Let me do this. Okay, in the meter, step number. What's it? Oh, eh. Can you see it now?
No.
Eh?
No.
I don't know what is happening now.
You can't see. Still.
You can't see it. Okay, let me try. Mm. Mm.
We'll do it next class.
Mm. Our time is up now, so I'll explain it maybe in the next class. Now it's
Yes, sir.
coming.
So it means we are done for the day now. No tutorial.
Yeah, I think we're done. So see you on Friday, ne?
Sir,
But
someone
yes,
asked
talk.
a question. Sir,
Yes, talk.
someone asked a question in the Can you please just go to that example? Say, I want.
Okay, since the time is up, allow me to maybe to log off. Maybe we can just talk about this next time. I'm going to save this page, I think so.
Okay.
I'm going to save it, then we will talk about it later, because now I'm struggling to show you.
Bye-bye.
Okay. So,
Janelle.